Hello, everyone, and welcome to day 3 of our 3-part webinar series, co-presented by AWS and Prevo. Today, we're talking about tertiary analysis in AWS, how to perform large-scale data analysis in AWS. Today, so I'm Simon Konstam. I'm joined by Aaron Friedman, Principal Solutions Architect at AWS. Yesterday, we talked about bioinformatics pipelines, the process of using data that is ingested from maybe on-prem sequencing devices or raw genomics data and processing that for use further down in the tertiary analysis that we'll be discussing today. We talked yesterday about how to use S3 as a backbone for large-scale, lightning-fast analysis. If you're interested in seeing the conversation that we talked about yesterday and you weren't able to join us, let me know. You can drop me a line in the chat and I'll send you a recording of yesterday's webinar. Those you can expect to also be up on the YouTube page, the AWS YouTube page here within a couple of weeks. Everybody who is attending today's webinar will get an invite to download today's webinar after the webinar today. And so you'll get a recording of today's, but if you want yesterday's webinar, please feel free to let me know. So as I mentioned, today we're going to be talking about tertiary data analysis. We'll be talking about building data lakes, how to do combinative analytics, and over 30 different tools will be discussed in today's presentation. And in large scale, there are 4 main challenges in managing, maintaining, and utilizing large scale data in AWS. So the first challenge that we've talked about previously is about ingesting data, simply getting the data landed into AWS. The second is choosing the right medium to store that data within AWS, finding the right balance of speed, of flexibility, of availability, and cost. And then from there, it comes to cleansing data, making sure that when you analyze data, that it's of the right format, that it's correctly quality controlled, so that you can actually glean useful results from that. There could be a lot of errant or extraneous data which needs to be manipulated or combined or transformed to do analysis from it. And then finally, once the data is in the right shape, you can utilize a bunch of different tools to glean insights and make that data actionable. So without further ado, I'm going to introduce Aaron to talk us through the beginning of our webinar. Aaron, take it away.
Thanks so much, Simon. So I think the way you framed it makes a lot of sense, right? The reality is, and for people listening, I'm a bioinformatician by training. I've worked in this space before AWS, and what's quite illuminating is that these challenges are not just unique to genomics. These are things that a lot of customers across a lot of industries, have to work out. And what's great about that in some ways is we can establish some common patterns and learn from other industries as well to positively impact the genomics community. So let's start with ingesting data, right? So as we look at data transfer and secure, connectivity, there's a broad set of AWS services that play in here as shown on the next slide, and 2 that I want to focus on from the data transfer piece are Storage Gateway and AWS Data Sync. Now, those are 2 services, right, that actually help you transfer large amounts of data to the cloud, right? So Storage Gateway, in a way, is you set up effectively a VM that can replicate data from an on-premises, say, file system up into AWS. Data Sync does it in a very similar way. It's highly performant, and it can really leverage sort of the entire throughput of your bandwidth and enable it to you in a lot of cases to do more with less. This is really important in genomics, especially if we look at, more recent, say, Illumina sequencers like the HiSeq and NovaSeq that are capable of generating, well over a terabyte of data per run. And that's per machine, right? So as you scale out and you're doing almost high throughput genomics in a lot of ways, the amount of data that you have to transfer up to AWS or to wherever your data may reside is a challenge that organizations face. And one of the things that we've really focused on here is how do we make that easier. And I think Storage Gateway helps you a lot with getting data to the cloud, and AWS Data Sync really turns it on overdrive. These data transfer services though are often used in context with or in conjunction with other AWS services that provide sort of improved and secure connectivity, right? AWS Direct Connect is a service that uses effectively a private backbone, right, and direct connectivity between wherever your on-premises system is. Say it could be within your lab and running a direct connect straight from there to AWS. Alternatively, you can use your traditional, say if you have a 10 gig pipe that's coming out of your data center or office or lab, and securing that connectivity right to the cloud using something like a site-to-site VPN, right? Where you're actually going through and sort of creating again that private network overlay connecting your on-premises data center to AWS. Now, these are only a few services, right, that are being used. We're seeing this a lot by genomics customers, but there's plenty of other options for data transfer, right? And not all of these are applicable, right? At least to the genomics use case. Theoretically, right, so our AWS Snow family, Snowball, Snowball Edge, and Snowmobile can be used to capture data as they're coming off the sequencer, and then you effectively use those devices almost to manually transfer data into AWS, say if you're shipping snowballs. You can use SFTP if you need it as well. Another set of data transfer services that we do see more for streaming data rather than genomics data. So would be data Kinesis, data firehose, data streams, video streams. And while those aren't necessarily always as applicable, say, to genomics itself, we do often see customers analyzing genomics data in conjunction with a broad set of phenotypic data. And if you're thinking about ingesting data, say, from more real-time systems, wearables, et cetera, some of the Kinesis family may come into play as we build out those genotype, phenotype analyses. And ingestion is really the first step, right? The next piece that we see from customers is really about how do we store that data. And really in terms of storing and cleansing that data, I think they're really go hand in hand, because storage is not just about where you're putting your data, but it's also about governance. It's about identity and access management. It's about tracking the data. It's about securing the data. And what we'll get into the next few slides are sort of the mechanisms that we're seeing customers use to enable that. And there's no better place, really, I think, to start than S3, Amazon Simple Storage Service. It's been around for, I think, almost 15 years now. And really what Amazon S3 provides is the scalability, the availability, the security, data management, and performance that you need for genomics. And S3 is an object store, which means it's virtually infinitely scalable. We have 11 nines of durability. We have, for S3 standard, it's about 4 nines of availability. But what it does in a lot of cases is it makes it very simple for you just to write your data there, right? So if you're writing FASTQ files or BAMs or CRAMs or BCL files from Illumina sequencers, S3 gives you the ability to scale out your reads and writes, and really stage your data in a way that is both performant for the needs that you want, right? Object stores are traditionally used more for long-term staging of data rather than like strongly consistent file systems, right? Or block storage. So what S3 is really ideal for in this use case is sort of serving as that source of truth. so that you can do things like, organize your data or ETL it into more optimal data formats to, for analytics and machine learning, right? So say converting your VCF files to Parquet and using some of the tools which we'll discuss in a little bit. But S3 really is that core foundation. And, cost is not the only benefit of S3, but it's worth highlighting and discussing that for a split second. So if you look at just, some of the list price, right, for storage, it is an incredibly, cost efficient mechanism to store terabytes or petabytes or even exabytes of data, right? If you're generating data from a bunch of sequencers, you're going to be very easily in the petabyte territory very quickly. So cost matters. And in this, it's worth highlighting here, right? This is sort of a rough sort of list price calculation of per terabyte. Now, a single genomic sequence, if you look at sort of the data files that are generated, a FASTQ maybe, or a set of FASTQ files that are gzip compressed, maybe 80 gigs, a BAM or a CRAM, sort of the aligned reads are going to sit between 50 or 60 gigs. And VCFs or GVCFs can be somewhere between 500 megabytes to say 5 gigabytes if you're looking at a genome VCF. So the actual cost per sequence per month is far less than this. And S3 actually, and the reason it's listed more is under $24 per month, and this applies to some of the others services up here as well, is there's a lot that you can get out of S3 by using the right data tiering and data storage strategy, right? So because you're using this as sort of long-term sources of truth, you can do things like moving your data after a period of time, or say more of your raw reads and FASTQ files, say from S3 Standard to Amazon S3 Glacier, which can reduce your cost by about 80% or even more. Similarly, right, because these files are often used again for staging even early on, you can actually use storage tiers like infrequent access to optimize for cost. And one of the things that actually now underlies a lot of this is something we call S3 intelligent tiering, which actually helps manage all those data access patterns for you, and you can build lifecycle policies and everything associated with that. So we wanted to sort of highlight that up front because it becomes a very, performant, durable, available solution that you can use while also optimizing for cost. And that's something that's really important as we generate, petabytes of data. And I kind of alluded to this before, but S3 is also, right, the foundation for a lot of AWS analytics services. AWS Glue, which we'll talk about in a bit, can be used for ETL, sort of using things like crawlers that actually look at your data across S3 and look for patterns and building out tables and schemas appropriately. Amazon QuickSight for data analytics or visualization can read data from S3. Athena is a managed Presto service that, right, again, can read and write from S3 as well as other data sources now, but S3 is the most common source of truth that we see. Lake formation, you could think about this in the context of data lakes, where not only are we concerned with how we store our data, but understand the governance, the access patterns, and again, making that data amenable for downstream analytics. Redshift is another tool that we see a lot of customers using for their data warehouse. At the same time, Redshift now has the ability to query, sort of within the highly performant MPP data warehouse that it has, but also extend out using Redshift Spectrum and reading and writing, say Parquet files that are partitioned on top of S3. And then Amazon EMR, right, is a managed managed AWS service that sort of sits or makes it easy for customers to use sort of Hadoop type analysis tools or the Hadoop file system, as well as Spark and a lot of other analytics tools. And we'll dive into that one in a bit, and Simon's going to cover off on that. But I think the really key takeaway here with S3 is that it is that source of truth. You can bring native AWS services to it, but you can also bring a lot of partner solutions, right? So, for example, if you're using Spark and you're using, say, Databricks, for example, you can use those, their capabilities to query data on top of S3. And once we have that data up there, once it's sort of in that almost raw zone that maybe you'd hear in a data lake, it's really key that we cleanse and organize that data, right? And the key sort of mechanism or architectural pattern that we see customers adopt is this concept of data lakes. And I think what's really key here, right, is you have a bunch. If you look at the bottom of the screen, right, you have a bunch of different services that can help you move data from wherever your systems are and land it on S3. Right, these could be real-time, more streaming type data sets, right? Say, right, from Kinesis Firehose or the AWS IoT Core Suite, or sort of more bulk data like genomics data that we've talked about before. But you need to have a way to track and automatically organize that data as it lands into S3 so that you can apply governance on top of it, that you can trigger workflows based on file types, and really provide that fine-grained access control for users as they begin to query that data with a broad set of analytics services, right? A few we talked about before on, say, on the previous slide. But also, how do we bring machine learning to that data, right? For example, using Amazon SageMaker to make it much simpler to build, train, and deploy machine learning models, say, that could be used to identify, say, different patterns within a patient's genome or an individual's genome, and use that to associate some type of risk profile as it pertains to a disease, right? So if we're looking for cancer or type 2 diabetes risk, all these types of things, right? I think machine learning is going to have a critical piece to play. But again, right, as we grow as organizations, as we think about how do we enable only the right individuals to access this sensitive data, the concept of data lakes and data management and governance really comes to play. One sort of foundational thing that leads into that is, or service, is AWS Glue. And Glue you can think of as a data source or a data service or an ETL service in a lot of ways that makes it easy to crawl different data sets that you have, whether it be on Amazon S3 or say a relational database or in a data warehouse on Redshift, and begin to understand almost implicitly based on what's in those data, in those files or tables, and begin to auto-populate a data catalog, which you can then use for downstream analysis. For example, connecting your Glue data catalog to Amazon Athena, so you know where all of your data sits across different data sources or silos. So it can work, of course, with S3. It could also work with RDS. Say if you have some type of phenotypic data that is sitting there, it can work with Redshift. There's a lot of flexibility that Glue provides to extract and organize and understand that data, so that it makes it a lot simpler for you as a customer or user of AWS Glue or any other analytics service to identify and analyze the right data that you need. So if we look at, for example, what this can look like, or how someone might consume data from S3 or from other data sources, let's just take a quick look at Amazon Athena. And this is something you could just imagine. Here is just a screenshot from something I was working on 1,000 genomes data set connected with ClinVar, and saying, okay, well, I'm looking for the actual frequency of genotypes as it pertains to a set of samples that I have in my population. In this case, I didn't necessarily do something like a full phenotypic lookup or look at, some type of pedigree, but instead I just said, okay, I'm just going to make it really simple. Anything in 1,000 genomes data set that has a sample ID starting with NA12, just give me only those data, aggregate, calculate the allele frequencies, and then join it with ClinVar. And this is something you can do really quickly, right? It's just writing, basic SQL really against your data set. But what you can find from these type analyses really quickly is you can actually use it as a quality control mechanism. So if you actually run this, what you'll find is there may be some, quote, pathogenic variants that are identified in ClinVar that actually have an allele frequency within the 1,000 genomes population that could be, almost close to 50%. And those are the types of things that, again, as you start to, run, sort of QA against your data sets and pressure test assumptions and hypotheses, that these types of ad hoc queries and analysis can give you a really good understanding of, well, is this data valid? Or, hey, if I have an allele frequency of near 50%, is this mischaracterized as pathogenic? Is there something else there? And you can start to dive in and, for example, going back, looking at alignments, there's a bunch of different things that you can do as you begin to explore your data sets in these ways. And it's really quick, right? You're writing this SQL. Athena only charges $5 per terabyte of data touched. So even for 2,500 samples as you're running ad hoc queries, it's incredibly cheap. You're not getting anywhere close to even a terabyte of data that's touched in any one of these analyses. And lastly, this is all, I think, more recently we've heard from customers that this is great. It's easy to build these types of solutions, but we need sort of a centralized service to make it easier for us to build these data lakes, right? That can ingest data, that can apply the requisite governance, the security policies that can enable collaboration and fine-grained access controls, and then also enable the monitoring and auditing of those data sources and data access. And that's the main reason we built, right, AWS Lake Formation is making it easier and helping customers go from building a data lake in months to days. And I think this is something that should be really powerful, right, for genomics customers, particularly when we start to look at going beyond genomics and looking at multimodal data sets, right? How are we analyzing genomes in the context of someone's microbiome profile or metabolomic profile or any of these other more longitudinal phenotypes, right? That could be existing within the electronic health record or outside of it. Having a robust data lake that underlies all of that is going to make it a lot easier for you, right, to enable discovery. At this point, enabling discovery, I think, is the exciting part, right? It's why we're here, and I'm happy to turn it back over to Simon as he dives into some of the ways that customers are gleaning insights from their genomics data on top of AWS.
Hey, thank you, Aaron. Fantastic coverage of Athena, of Glue, of Lake Formation. Thank you for setting the stage so nicely here. Fantastic. Yeah, so like Aaron mentioned, the big goal of getting all of this data into AWS, to assembling it, making it available for analysis in one location, is this genetic trait association wide study. So, making the link between genetic variations and observable traits across various cohorts. And using the previously discussed bioinformatics orchestration pipelines that we talked about yesterday, and getting it landed in a secure location like we had talked about the day before, provides teams the ability to do these very wide, very powerful genome-wide or exome-wide sequence analyses across large cohorts and large populations. Whereas, maybe a decade ago, we were looking at associations between a variation in one allele to genetic trait associations in particular populations. Now people are doing genome-wide association studies or phenotype-wide association studies across petabytes and petabytes of data. And when folks are talking about analyses at that scale, the tool that we end up hearing about the most is Broad Institute's HAIL. So HAIL is the industry-leading solution to process high-volume genomics data sets and glean insights. The HAIL project was started by the Broad Institute in 2015 and is an open source Python library built to run very large genomics tertiary analysis workloads on Spark. So this allows users to tackle petabytes of data, whereas previous tools had been focused on processing hundreds or maybe thousands of genomes or exomes. HAIL is frequently used on workloads orders of magnitude in that size. And I actually looked at for a couple of days ago where HAIL was used to look at, I think, 600,000 genomes wide association studies. HAIL is specifically built for genomics, and it's got domain-specific primitives and statistics tools that are embedded within it to provide for really powerful quality control and data manipulation and analysis on genomics data at a really wide scale. So HAIL allows users to begin yielding insights, processing, from process bioinformatics data. It accepts really industry common formats like VCF, Plink, Gen, BGen, and it uses this incredibly powerful data convention called HAIL matrix tables. So HAIL matrix tables allow for multi-dimensional data sets to be combined and compiled along with annotative or phenotypic data. So that could be, phenotypes, it could be EHR data. That data can be super complex. And we've even seen teams pull in multiple single cell RNA sequences from patients and compile those on top of each other in this multi-dimensional analysis in the HAIL matrix table. So it allows for really kind of complex data formats to be analyzed at once. Or, we've seen other teams combine whole genome sequencing with full EHR data from a patient's, longitudinal kind of lifetime in their clinical studies. So you can do all sorts of different analyses in there. And what's great is that HAIL was designed for genome-wide association studies. It has all of these quality control techniques. It has data set transformations built in. It has all of the topical charting visualization techniques included in it out of the box. And so it takes minutes to start analyzing wide breadths of data and performing statistics, to perform QQ plots or produce Manhattan plots. So we're very excited to announce today the general availability of HAIL's Quick Start on Amazon's Elastic MapReduce. A fantastic team here at Prevo collaborated with Goldfinch Bio and the AWS team to provide a quick start that allows teams to be able to run HAIL fully functionally on Elastic MapReduce in less than 30 minutes. I will include a link in a couple of pages here on how to get to that quick start. We'll also send this to you in the follow-up to this conversation here today. What's fantastic is that we didn't just provide the ability to run HAIL on EMR, we also show you how to start a SageMaker notebook to interactively explore and manipulate data. And we walk through a demonstration of how to start using HAIL on the 1,000 Genomes project right out of the box. So you are also able to use spot instances. So teams in the past had issues running, when you run petabyte-sized data, that starts to become an expensive process very, very quickly. And so out of the box, we provide the ability to run these wide data analyses on spot instances with SageMaker notebooks. And to add to that, we also include Ensemble's VEP, Variant Effect Predictor, to help teams do annotation and analysis very quickly in that startup. So let's take a look at what this quick start actually looks like when you run it. We provide these to end users as two elements in a service catalog. And you can share this with anybody from your team that you want to provide access to. So if you have a wide-ranging team who all want their own clusters, this quick start and this service catalog entry gives your team ability to securely and discreetly run different Hail on EMR clusters and provide all of your researchers with their own Hail SageMaker notebook instances as well. And so, you don't have to worry about anybody stepping on their toes, and each of your researchers can run this on spot instances securely. So the cost benefit is definitely there as well. In that startup, we'll walk you through how to do quality control, all of the different charting techniques that you'll want to be able to do. And here we're looking at some quality control that you can see how easy Hail makes it to do really beneficial quality control on your wide data sets. And from there, you can run things like Manhattan plots, although this data doesn't look like it's cleansed enough to actually provide any useful statistics or results. We walk you through how to get from, kind of fully formed data through quality control and into charting in very short order. So if you run the biotech blueprint, you'll see this, the Hail Quick Start as part of your biotech blueprint, or the Quick Start link that I showed here on this page, aws.amazon.com/quickstart/architecture/Hail will get you into that Quick Start, and we'll send a link out to all of the attendees after our conversation here today to go ahead and get started. So once you make it through using Hail, or you want to do wider phenotypic analysis on your data, visualization can definitely be a helpful element in doing that tertiary analysis. Quick Start, Amazon's Quick Start, is a really fantastic place to start in doing analysis on wide data. Quick Start allows you to utilize data that's available in S3, Athena, Redshift, RDS, and provide really quick and easy visualizations that you can share across your entire team. Quick Start is an excellent tool at really wide data analyses. There are a couple of AWS technology partners, namely Tableau and Tibco, who have a software called Spotfire, which are also really fantastic and have some tools specifically geared towards genomics data analysis that are fantastic in this space as well. So I wouldn't be able to leave this conversation without giving a few suggestions centered around monitoring and data security. When you have wide genomic data in AWS, it's of course of chief concern to make sure that we know how much data is in the cloud, how that data is being accessed, and making sure that if it's being accessed in a way that we're not that we're not intending, that we as researchers are able to take quick response, or that the right people, the right folks have that alert in their hands. So to be able to understand how much data you have landed in the cloud, CloudWatch is a fantastic first line of defense in understanding what data and how much data is being stored in AWS. CloudWatch is enabled by, kind of by default. You can point those metrics at your S3 buckets and understand how many bytes and how many objects are being stored in AWS at any time. CloudWatch can also be used to turn on metrics, and this we find is really helpful for teams who have budgetary restrictions or have, need to make sure that they're only storing as much data as they intended in AWS. To set a CloudWatch alert on a metric is very simple, and then that alert can be pointed towards simple notification service, so you can get a text message or an email when you go over the volume that you intend for a certain bucket of data. Or using AWS chatbot, you can actually receive these notices to Slack, which is what we do internally at Prevo. And that can be a very helpful way to make sure that you're receiving the right alerts at the right time in a medium that you're actually going to be looking at during the working day. We also work with a company called Cloud Checker. Cloud Checker is a great AWS partner, and they also have their own suite of S3 analysis tools. It can help you understand trends across different S3 buckets per a given time. And what's great about Cloud Checker is that they have really good tools when you do tagging of data. So data that's stored in S3 can be tagged, and those tags can be turned into cost allocation tags. So for example, a lot of our teams will have breakdowns like this, where each of the departments, the data for each of the departments have to be tagged. And that data can then be allocated and combined so you can understand trends on a daily, weekly, or monthly basis broken down by department. And we find that this is a really powerful way to make sure that that teams are responsible for the amount of data that's being stored in AWS in those different buckets, and that that the right responsibility is going to the right places for maintaining and managing that data. Tags can also be used to apply lifecycle policies, and so perhaps these different departments have different different lengths of time that they need that data to be, let's say, stored in standard tier inside of AWS. You can move, you can lifecycle data from standard tier to Glacier or to infrequent access, what have you, based on those tags. So tagging should definitely be used as part of a good management procedure for data in S3. And then last but definitely not least are making sure that you have the right security permissions on your data landed in S3. And Aaron talked about this a little bit earlier, but S3 has really great tools around making sure that data is not accessible from folks who are not intended to have access to that data. We've seen, as the races have heated up around bioinformatics around the world during kind of the current climate, S3 buckets are being tested more often than we've ever seen before at Prevo. And one way to make sure that we're really keeping arms around our data and making sure that it doesn't leak to anywhere that we don't intend it to and is locked down are KMS encryption keys. So KMS encryption keys can be used to encrypt buckets by default. This is a really good best practice, kind of regardless. KMS keys cost almost nothing, and can make sure that bucket data, data that's stored in a given bucket, are encrypted with a KMS key by default, so that they're encrypted at rest. Again, the costs are very low, and the amount of security that this provides is quite high. The second thing that we would recommend doing is, as of a couple of weeks ago, Amazon Guard Duty can now be set to protect S3 buckets. So Guard Duty uses machine learning algorithms to analyze the access data for in this case, S3 buckets. And if they see anomalous data access, they can actually alert users or alert the management team for that AWS account to that suspicious activity. Guard Duty, again, costs very, the cost is very low. The results that we've seen gleaned from this are pretty good. And so in those cases, we would definitely recommend using Guard Duty to protect S3 buckets, especially those that are of sensitive nature. Excellent. So what did we cover today? So we talked about landing your data in S3. It's the home for all informatics data over the long term. S3 should really be considered the home of all bioinformatics data. Use Hail on AWS. We'll send you a link to the quick start for Hail. We're really excited to have worked with AWS and with Goldfinch to create this really awesome tool. And if you haven't used Hail before, we promise it's not as scary as it sounds. It's a really excellent tool to be able to do tertiary analysis in AWS and start gleaning results from that data. We'll make that accessible to all of you, and feel free to reach out to me and I'll connect you with my team. If you do have questions about either the quick start, how to get started, or how to use Hail for your particular workload, we would love to work with you to understand how to approach those situations. So please don't hesitate to reach out to me. And then AWS has a fantastic suite of tools that allow you to automate cleansing, data management, inquiring about data with Glue and Athena, or using lake formation to very quickly put together your data lakes. And then as the final wrap up, this is the third part in a 3-part series. Yesterday we talked about bioinformatics pipelines. The day before we talked about strong data foundations and infrastructure foundations in AWS. We will be sending out to all attendees the recordings of these webinars, but please reach out to me if you would like a recording sooner than later. We'd be happy to provide that to you as well. Thank you all of you for attending today's webinar and for being with us this week. We look forward to chatting with you again soon, and thank you very much for your attendance.